Hello everyone. In this video, we will learn about decision tree classification. So what is this decision tree? That's a tree-like structure. Actually, it mimics the human decision making by splitting the data into smaller and smaller subgroups based on certain decision criteria or certain rules. So it is a supervised learning algorithm. It can be used for both classification and regression methods. Classification is used for predicting categorical variables, and for regression is used for predicting continuous values. So this is the form of decision tree where you can see that there will be a root node and there will be some decisions. For in this diagram you can see it can be yes or no type of answers, and based on this decision the next node will be decided. So we'll be having several internal nodes and some decision nodes. So at the lowest end, the lowest level, you can see the leaf node. So at this leaf node only the classification happens. So you will get the classes on at the leaf nodes. So this is the typical structure of a decision tree. There will be a new root node, then there will be decision nodes and the final leaf nodes where you will be getting the classes. So how does this decision tree algorithm works? So first we have to start with a root node. Root node, as you know, it is the topmost node of a decision tree. So at the root node we will be begin with the entire training data set. So we have to select the best feature to split. How will you selecting the best feature? We have to evaluate the splitting criteria, which is known as attribute selection measure. So then we have to split the data set, then divide the data set into subsets based on the selected features possible values. It can be categorical or it can be numerical. So we have to create a decision node with branches for each subset. Then we have to do recursion for each child node. If it is pure means then create a leaf node with that class label. Pure means all the examples belongs to only one class. If it is empty, then create a leaf node with majority class of the parent. Otherwise you have to repeat the steps 2 to 4. Then what is the stopping criteria? So the stopping criteria is that if all the instances at a node belongs to the same class, that means no feature provides any useful split, then that is a gain is 0. So in that case you can stop. So the final output will be a tree structure. The internal node represents the decisions based on feature values, and the leaf node represents the predicted class labels. So this is how a decision tree algorithm works. But how will you decide on which node, which data to be split? So that is based on the attribute selection measures. So we have to identify the attributes which we consider as the root node. So first one, when you are creating the decision tree, you need to decide which feature will come as the root node. So that is based on the attribute selection measure. So there are different attribute selection measures to identify the attribute which can be considered as the root node at each level. So the two popular attribute selection measures are, one is information gain, another one is Gini Index. So the information gain for categorical attributes and for Gini Index for continuous attributes. So we will be concentrating on Gini Index. So I'll be solving a problem based on Gini Index. So here this Gini Index attribute selection measure is used for CART, that is categorical and regression trees. So it uses the Gini method to create split points. So basically this Gini Index measures the degree of impurity in a data set. So the lower the Gini Index means the node is purer. So that is mostly one class. Higher Gini Index means the node is more mixed. So more class diversity is present. So how will you find the Gini Index? You can find the Gini Index by using this formula. So Gini Index is 1 minus summation of this I is equal to 1 to n pi, where this pi is nothing but it is a probability of picking a data point of that particular class. N is the number of classes. So this cart, as I already said, cart and regression trees uses Gini method to create binary split. So for example, how this formula can be used, I'll just explain. Suppose you have a node with the following class distribution for 4 instances. There are 4 instances where there are, belongs to class A and 6 instances of class B. So how will you find the probability that the instance belongs to class A? So the probability of A is nothing but, so the total instances we have 4 plus 6, that is 10. So out of 10, 4 is for class A and 6 is for class B. So the probability of class A is nothing but it is 4 divided by 10. That is 0.4. And the probability of class B is 6 divided by 10. That is 0.6. So you got the probability for each class. Now you can substitute in the formula for Gini index for calculating the Gini index. So what is that one? It is the summation 1 minus summation of the probability of each class. So 1 minus PA, that is 0.4 square, minus, actually it is 1 minus, we can write it, if I take minus outside, I can say 0.4 square plus 0.6 square. That is what is called the summation is there. So this, when you are doing it, you will be getting the answer as 0.48. So this is the Gini index for that particular class, you can see. Next, how will you construct the decision tree using Gini index? So a data is given, the data set will be given. So what you have to do is you have to find the Gini index. Gini index for each feature you have to find. Then what you have to do? We have to find the weighted Gini index. So this is weighted Gini index. After that, you have to find the splitting criteria, whether which feature has to be taken as the root node or the parent node. Root node is the topmost. So at every level, you have to choose the node. So it can be intermediate node, which we call it as parent node. So how will you select which node to be chosen? So that is based on the Gini index. The attribute with the minimum Gini index is chosen as the splitting attribute. So you have to calculate the Gini index for all the features. Then the attribute with the minimum Gini index you have to choose as the root node. So let us consider an example here. So we have the features here: past trend, then open interest, trading volume, and this is the classification which we are going to do, whether the return is up or down. So for each feature we have to find the Gini index. So for here past trend, for positive, so how many data samples are there? You can count here 1, 2, like that, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you have 10 samples there. Out of that, 6 are positive. 1, 2, 3, 4, 5, 6. 6 are positive. So the past trend positive, the probability is 6 by 10. A past trend negative, the probability is 4 by 10. So the Gini index of the total one is 1 minus 4 by 10 whole square minus 6 by 10 whole square, that is 0.48. Since we have 6 positive and 4 negative classes for 10 total records. Now calculating the Gini index for past trend. So here what we are doing is, so here past trend, this column we have chosen because we need this column, that is a feature column, and this is the output which you are going to get, that is a classification. So we have taken these 2 columns here. These 2 columns, the first column, this is for the feature and this is for the prediction. So a past trend, already we have seen it is 6, positive is 6 by 10 and negative is 4 by 10. So now what we have to do is, when we just consider only the past trend positive, here 1, 2, 3, 4, 5, 6. So in this positive, you need to see how many of it are up. So 1, 2, 3, 4. So 4 of them are up, and how many? 1, 2, 3, 4, 5, 6. Out of 6, 4 are up and then the remaining will be down. So past trend is equal to positive and return up, that is 4 divided by 6, because the total positive are 6 and out of 6, 4 are up and out of 6, 2 are down. So past trend is equal to positive and probability return is equal to down. You will be getting a probability as 2 by 6. So how will you find the Gini index for this? That is 1 minus summation of the probability. So 1 minus 4 by 6 the whole square plus 2 by 6 the whole square. So you got it as 0.45. So that is for past trend positive. Similarly, you have to find for past trend negative. So for this negative, this one, I can say this one is for -1, then 2, 3, 4. So there are 4 rows with 4 samples, that is with negative. So out of this negative, how many are there? Down 1, 2, 3, 4. So we have 4 negative and all 4 are down, means up is 0. So when we are talking about past trend negative and return up, the probability is 0, because you can see that there is no entry for up here. For the negative entry, there is no up. So for the past trend negative and return down, you can see all 4 negative, we have the return as down. So you are getting the probability as 4 by 4. Now you have to evaluate the Gini index for this case. So what is the Gini index? Now this is 1 minus this square, probability square, minus this 4 by 4 whole square. So you got it as 0 there. Now what you have to do is, now we got for the past trend, there are 2 possibilities. One is positive, another one is negative, and for each case we have found the Gini index. Now what you have to do is, you have to take the sum. So the Gini index for past trend is nothing but, for past trend positive we have the probability as 6 by 10 and negative it is 4 by 10. And positive and negative Gini index we have calculated separately. So when you are taking the total Gini index, it is the overall, that is 6 by 10. Because 10 samples are there, out of that 6 are positive. So 6 by 10 into Gini index of the positive one, that is 0.45 we have evaluated. Then plus the negative are out of 10, 4 are negative. So 4 by 10 into, what is the Gini index? We got it as 0. So that into 0. So you got it as 0.27. So this is the Gini index corresponding to the feature past trend. Now how many more features are there? So this is done, past trend is done, we are done with past trend. Next one we will consider open interest. So for calculation of Gini index for open interest will see out of 10 how many are there with high? 1, 2, 3, 4. So 4 entries are high out of 10. So we can see here for 4 entries high, 4 by 10, and remaining are low. So for probability of low is 6 by 10. Now we will consider each case separately, because for high we need to find whether the return is up or down. So out of 4 high, you need to find how many are down. So 1 down is here, then 1 down is here. So out of 4, 2 are down. So that means 2 are up. So 2 with up return and 2 with down. So open interest high and return up, the probability is nothing but the total entries are, for high it is 4. Out of that 4, 2 are up. So the probability is 2 by 4. And for down, down also it is 4. Out of 4 open interest high and down it is 2. So 2 divided by 4 you got it. So how will you find the Gini index? It is 1 minus 2 by 4 the whole square plus 2 by 4 the whole square. You got it as 0.5. Now what you have to do? The next case is for this low. High one we have considered. So next one is this low. 1, 2, 3, 4, 5, 6. You have 6 entries for low, and for each low, for this low we need to find how many up and how many down are there. So let us consider up. For low, 1 here, 2 here, then for low, okay, only 2 are up. So 1 low, 1, 2, 3, 4, 5, 6. We have 6 entries for low. Out of that 2 are up. So the remaining 4 are down. So open interest low and return up, you got it as total 6 entries. So it is 2 divided by 6. So open interest low, we have 6 entries there. So the denominator will be 6, and out of that how many are down? We have 4. So probability you got it as 4 divided by 6. And you have to find the Gini index, that is 1 minus this probability whole square minus this probability whole square. So you got it as 0.45. So there are no more entries like that. So we have only two cases, one is low and one is high. So for both the cases, we have found the Gini index. Now we have to find the overall Gini index. So the weighted sum of this Gini index, separate Gini index will give you the total Gini index. So how will you find? It is the overall probability is given 4 by 10. For high it is 4 by 10 and for low it is 6 by 10. So 4 by 10 into this Gini index plus 6 by 10 into this Gini index. So 4 by 10 into 0.5 plus 6 by 10 into 0.45. You got it as 0.47. So you got the Gini index for open interest also. Now you just see open interest also we have done for past trend, we have done for open interest. Now we have to consider trading volume. That is the next feature. So for calculation of a Gini index for trading volume, you need to see how many high are there. This is 1, 2, 3, 4, 5, 6, 7. So there are 7 rows with high entry. And you need to, so total entries are 10. So out of that 7 are high. So that means 3 are low. So out of this high, you need to see how many are up. 1, 2, 3, 4. 4 are up. So total high is 7. So out of 7, 4 are up. So the probability of high and up is 4 divided by 7. So the probability of high and down, it is out of 7, 4 are up means 3 are down. So you got 3 divided by 7. So the probability you got, now you have to find the Gini index. Gini index is nothing but 1 minus this probability square minus this probability square. So 1 minus 4 by 7 square plus 3 by 7 square, you got it as 0.49. Now we have to we have considered high case. Now we have to consider low. So low we have 1, 2, 3 entries are there for low. And you just see how many are there for down. 1, 2, 3. So for all low cases, we got it as down. So the probability is basically 0. So the trading volume low and return up is 0 because there is no up entry there for trading volume low. And for trading volume low, return down, you have 3 down entries. So you got it as 3 by 3. So now find the Gini index. That is nothing but 1 minus this square plus this square. So you got it as value is 0. So that Gini index also found. So there are no more entries. We have only two options, that is high and low. So both the Gini index you have found. Now you have to find the overall Gini index. So overall Gini index is weighted sum of this Gini index. So this one probability is known. So 7 by 10 into this Gini index plus 3 by 10 into this one. So 7 by 10 into 0.49 plus 3 by 10 into 0, you got it as 0.34. So the Gini index for trading volume is also done. Now you just check in the original table. So we don't have any more features left. We have found the Gini index for past trend, open interest and trading volume. And this column represents the prediction column. Okay, so this is the classification up or down. So all these three, now we have to compare the Gini index you have calculated for all these three features. So attributes is past trend, that we got it as 0.27. For open interest we got it as 0.47 and trading volume we got it as 0.34. You can see trading volume is 0.34, open interest is 0.47 here. Then for past trend you got it as 0.27 here. So now compare the Gini index of all these three features. Now what we have to do is, based on the attribute selection measure, the feature which gives you the minimum Gini index has to be chosen as the selection criteria, means to be taken as the root node. So out of this, if you see, the past trend is having the minimum Gini index. So the past trend will be, you will be choosing as the root node. So let us consider the next step. So past trend we have chosen as the root node here. So in past trend you can see there are only two options here for past trend, positive and negative. So two branches we have kept for past trend, positive and negative. So let us consider this positive side first. Okay, so past trend we are considering only the positive entries. Then we are the other features we have taken, open interest and trading volume. So based on the initial table we have calculated. So the past trend, we have taken this entries only, positive, positive, this positive and this positive, and corresponding to that what are the values for open interest and trading volume, we have kept it in this table. Okay, so now what we have to do is, now this is our new table, and next the first feature we are going to consider is open interest. So how many entries are there? 1 2 3 4 5 6. So total there are 6 rows. Out of that, open interest you have two options, low and high. So out of 6, 2 are high and 4 are low. So you can see here open interest high is total entry 6, out of that 2 are high. So the probability is 2 divided by 6, and for open interest low the probability is 4 divided by 6. Now what you have to do is, for low you need to see for the low cases, that is 1, 2, 3, 4. Check up case 1, 2. So only 2 are up, and for low case remaining are, out of 4, 2 are up and 2 are down. So you got, for open interest high, return up probability is 2 by 2. So open interest high we will see, okay, high has been taken. So high is this one. So high, this entry is up, this entry is also up. We don't have any entry for down for open interest high. So for the down one, the probability is 0, and for high it is up, there are 2 entries. So for return high up, open interest high and return up, probability is 2 by 2. Down, as I already said, there is no entry, so the probability is 0. So the Gini index you can calculate as 1 minus 2 by 2 square. Actually this is square plus square of this one's square. So you are getting the answer as 0. Next one, so only one case we have taken high. The second one is consider open interest low. So for open interest low also we found it. There are 2 cases for up. So we got it for up. It is 2 by 4. Total low is 4 entries are there. Out of the 2 are return up and 2 are down. So the probability for open interest low and return down is 2 by 4. Now find the Gini index. So it is 1 minus the square minus 2 by 4 square. So you are getting it as 0.50. Now what you have to do, there are no more entries there, and in open interest high and low both we have considered. Now you have to take the weighted sum. So weighted sum is nothing but this one into the first Gini index. First Gini index is 0, and the second one 4 divided by 6 into the Gini index corresponding to that, that is 0.5. So 2 by 6 into 0 plus 4 by 6 into 0.5, you are getting it as 0.33. Now what is, so for open interest, for past trend, open interest we have found. Now next feature is trading volume. So we'll be considering the next feature, trading volume here. So for trading volume, we have 4 by 6 and 2 by 6. That is already done. 1, 2, 3, 4, 5, 6. Out of 6, 1, 2, 3, 4. 4 are high and 2 are low. So high probability is 4 by 6 and low probability is 2 by 6. That is what is written here. So a trading volume 4 by 6 and 2 by 6. Now for a trading volume high and a trading volume high and return up, how many you have? So here 1 is there. Then here 1, 2, 3, 4. All 4 are up. We don't have down there. So here 4 by 4 we got it as, and for down probability 0 because we don't have an entry for 0. So now find this one square, or this is square. 1 minus 4 by 4 square plus this one. So you got the index as Gini index as 0 here. Now we have considered trading volume high case. Now we have to consider for trading volume low case also. For trading volume low, you can see here 2 entries are there and both of them are down. So we don't have an up entry there. So 2 entries for low, and so here it is up entry is 0, so the probability is 0, and 2 entries for low and both 2 are down here. So you got it as 2 by 2. Now find the Gini index, that is 1 minus 0 square plus minus a square 2 by 2 square. So you got it as 0 there. So now you have to find the weighted sum because you don't have any more classes there. We have only two types, high and low. So both we have found. Now you can sum up this one. So the total Gini index, that is 4 by 6. So 4 by 6 into the 0 plus 2 by 6 into this one. So 2 by 6 into 0, you got it as 0 as the Gini index. Now, if you go back, you can see that we have found the Gini index for open interest as well as trading volume. Now you have to compare the Gini index of these two and select the one which is having lowest Gini index. So here we are again considering, so open interest we got the Gini index as 0.33 and for trading volume we got it as 0. So you can see we got it as 0 here, and for trading volume you got it as 0.33 there. So when you compare this two, we know that this trading volume is having the lowest Gini index. So that should be our next decision node. So we have taken, so past trend positive we have considered. Then next node is trading volume. So here for past trend negative, actually if you see for past trend negative, what is happening here? I'll show to the original table. So past trend negative, this is one case. This is another case, this is negative, this is negative. So how many are there? 1, 2, 3, 4. So here it is down, then this one also down, this one also down, this one is also down. So the decision is directly down. So if the past trend is negative, you can directly say that the return is down because there is no ambiguity in that, because it's a pure node. So here for past trend, we can directly put it as down there. We don't need any attribute selection measure this particular node because the decision is already done. This is our leaf node, you can see here down. And now coming on to this trading volume, we have chosen trading volume as the next decision node there. So we have to split the node further. So if you see the trading volume, what are the cases possible? We have for the trading volume high. So in high case it is up, here it is up, here high is up. So here in this case high down, high down, high down. So we have high and here also high up. We have high up and down there. So we'll be doing again this one, past trend. Okay, here trading volume. Now you have to do for trading volume high. So continuing like this, we'll be getting for trading volume high, we are getting the return as up, and for trading volume low, we are getting as down. So this is, how we will be using it. And for every node, we have to find the Gini index for making the next decision. So here it is done. So this is the final decision tree. So we can easily find if the past trend is negative, the classification will be down. And if the past trend is positive, then the trading past trend is positive and the trading volume is high, then the classification will be up. And if the past trend is positive and trading volume is low, you'll be getting down as the classification. So Gini index is much simpler as compared to information gain, because information gain has logarithm function for evaluation for calculating entropy in information gain. So basically this Gini index is preferred over information gain. Hope you understood how the decision trees can be used for classification purpose, and how Gini index can be used for solving the problem. Maybe for classification, how Gini index can be used for classifying the data set. Thanks for watching. Thank you all.